Let's look at another periodic function, and let's figure out the Laplace transform of it. This function is f of t is equal to f of t plus 2a. So which means the period here is 2a. Okay, f of t is equal to, the function itself says it is m when t is between 0 and a, and when t is between 2a and a, it is minus m. Okay, we know the Laplace transform of f of t for a periodic function. It is 1 by 1 minus e to the power of minus s capital T, integral of 0 to t capital T, e to the power of minus st f of t dt. Okay, now let's do the necessary substitutions. 1 by 1 minus e to the power of minus s, t is, time period is 2a, right? Integral of 0 to capital T of e to the power of minus s t f of t dt. So what we have done here is, here this t is 2a, right? 0 to 2a. But since it is discontinuous in nature, we can split this integral into two parts, right? 0 to a and a to 2a. So integral of 0 to a of e to the power of minus st. Now when it is 0 to a, it is m, right? So we can write m dt plus integral of a to 2a of e to the power of minus st. Now when it is a to 2a, it is minus m. So minus m dt. Okay, let's take it further. Now here m can be taken out. Here also m can be taken out. So which means I can take out this m here. I'll be left with e to the power of minus st dt. So we can integrate that. So that would be e to the power of minus st by minus s from 0 to a. Okay, let me write the proper. Okay, here minus can be taken out. So minus e to the power of minus st by minus s. Here it is a to 2a. Okay, m by 1 minus e to the power of minus 2as times. Now here minus can be taken up. And let's do the substitution as well. A for t. So minus a to the power of minus sa by s. And when we substitute minus, but because of this minus in the denominator, this becomes plus. E to the power of minus 0. Actually, this becomes a 0. So which is 1. 1 by s. Now minus, again here what we can do, we have to substitute 2a. So minus, let's bring it up, e to the power of minus 2as by s minus times minus plus it becomes, right? Now let's substitute a. So e to the power of minus as by s. Now let's see what happens. M by 1 minus e to the power of minus 2as minus e minus as plus 1. all the denominator is s, so we can just, so plus e to the power of minus 2as minus e to the power of minus as by s. That s in the denominator can be brought out. So s times 1 minus e to the power of minus 2as, and this becomes e to the power of minus 2as minus 2e to the power of minus as plus 1. Now, if you look at this, this is a quadratic equation, right? Here it is, there is a square, here there is a 1. Okay, let's say x is equal to minus as. Then what happens? This becomes, let's say, e to the power of minus as. Then what happens? This becomes x square minus 2x plus 1. And this can be written as, so this becomes m by s times 1 minus e to the power of minus 2as, and this can be written as x is e to the power of minus as minus 1 square. Okay, now if you notice, in the denominator we have 1 minus, in the numerator we have e to the power of minus as minus 1, and there is a there are differences, but you somehow get the feeling that some kind of manipulation can be done with respect to these two. So they should be in the same order. So m by s. Okay. Now what I'll do is, since it doesn't matter whether it is 1 minus e to the power of minus as square or this, they both mean the same thing. You can take the square of this, minus 2 times this and this, plus 1 square, or you can do the square of this, so 1 minus 2 times this plus e to the power of minus 2. So it boils down to the same thing. And here 1 minus e to the power of minus. Now here what I can do is I can split this into 2. So 1 plus e to the power of minus as. So again, if you multiply it, what do you get? 1 minus e to the power of minus as square, right? Square. Okay. So now this and this, one of this gets cancelled out. M by s times 1 minus e to the power of minus as by 1 plus e to the power of minus as. Now, if you look at this, can you think of some way by which we can convert it? If you remember e to the power of, if you remember e to the power of x plus e to the power of minus x by 2. What is this? This is equal to cos x. Yes, similarly, e to the power of x minus e to the power of minus x by 2 is equal to hyperbolic sine x. So we need to bring it to that form. So how do we bring it to that form? If we if let's take out this e to the power of minus as, or in other words, let's put in place of 1, let's put e to the power of as by 2, because that is what we want. We want a positive exponent. But to cancel that or to neutralize that, let's put e to the power of minus as by 2 outside. You will see why I am putting by 2. Okay. Now minus, we have to take half of it out, isn't it? So e to the power of minus as by 2. So basically we have taken half of this out and balance it. Okay. Similarly, in the denominator, let's take out minus e to the power of minus as by 2 times e to the power of, to balance it, as by 2 minus e to the power of minus as by this particular step. Look over it carefully till you understand it. Now here these two get cancelled. M by S. Now what we can do is we can write it as AS by 2 plus e to the power of minus AS by 2 divided by 2. Let's introduce this 2. And just to cancel it out, let's put 2 in the numerator also. E to the power of AS by 2 minus e to the power of minus AS by 2. Right? So M by S. Now what is this? This is hyperbolic sine. No, my mistake. This is supposed to be plus and this is supposed to be minus. Yes. See, silly mistakes. So you have to be very, very careful here. So this is what? This is hyperbolic sine of AS by 2. And this is the, if you look at the inverse of this, multiplicative inverse, that is cos. Since it is multiplicative inverse, it will go to the denominator, AS by, so which means M by S sine by cos is hyperbolic tan of AS by, now this is AS by 2. Now if you want to write this in terms of T, then remember, since A is equal to T by 2 or 2A is equal to T, that means AS by 2 is equal to, if we take this to the other side, it becomes T by 2. So T by 4S. So this can be written as M by S hyperbolic tan of T by 4 as well. This is the Laplace transform of f of t, where f of t is equal to m when t is between 0 to a, and when t is between a and 2a, it is minus m. And this is called the square wave function. Okay, I think that's enough for today. Bye.